gravitomagnetic equilibrium and the formation of orbital systems, a harmonic geometric approach to the balance of energy. Point 1. Introduction. This work proposes a conceptual framework for understanding the formation and stability of matter across scales, based on the interaction between two fundamental and opposing tendencies, gravitational cohesion and magnetic expansion. The model is situated within a broader harmonic geometric interpretation of the cosmos, in which structural balance emerges from the dynamic equilibrium of forces governing energy distribution. The central hypothesis is that orbital systems, ranging from atomic to stellar scales, arise as necessary configurations to regulate energy density when gravitomagnetic interactions exceed certain thresholds. 2. Theoretical framework. 2.1 Gravity as a cohesive principle. Gravity is defined as a concentric force responsible for concentric cohesion of energy-forming matter, the increase of energy density, and the structural formation of spherical and uniform nuclei in continuous increase of scales. Its action leads to compression, increased rotational velocity, and enhanced internal cohesion. 2.2 Magnetic forces as expansive regulators. Magnetic forces, in this model, are generalized as expansive mechanisms that redistribute energy, counteract excessive concentration, and enforce spatial reorganization through orbital structures with an increase of these in n successive values. This definition extends beyond classical electromagnetism and should be interpreted as a cosmic scale energy redistribution principle to achieve equality in the energy density of the cosmos. 3. Model description. 3.1 Threshold of gravitomagnetic equilibrium. At low energy levels, the interaction between gravitational and magnetic forces does not produce significant structural constraints. However, as mass accumulates, a critical threshold is reached at which energy density increases sharply, gravitational compression intensifies, and magnetic forces are compelled to respond. This threshold defines the onset of mandatory orbital structuring. 3.2 The hydrogen atom as fundamental unit, level 1. The model identifies the hydrogen atom as the first system in which gravitomagnetic balance becomes strictly enforced. Orbital structure emerges as a necessity rather than a possibility, and charge balance corresponds to orbital configuration, n equals 1. By analogy, at the stellar scale, this corresponds to a minimal system, a star with a single orbiting body. Thus, hydrogen is defined as the fundamental unit of balanced orbital formation. 3.3 Progressive instability in larger systems. Beyond this equilibrium point, gravitomagnetic imbalances begin to manifest and accumulate. Orbital systems become increasingly constrained, and energy density rises beyond sustainable limits. This culminates in instability thresholds such as heavy atoms, e.g., uranium, stellar collapse events, e.g., supernovae. In these cases, magnetic expansion dominates, leading to system disruption. 4. Mechanism of instability. The instability of large systems arises from coupled effects. Increased gravity gives higher rotational velocity, higher rotation gives stronger centrifugal force, stronger forces and velocity gives orbital compression, compression gives reduced effective volume, and this produces a critical contradiction. The system requires more volume to reduce energy density, but gravitational effects simultaneously reduce available volume. Once this contradiction becomes unsolvable, the system undergoes self-destruction driven by hyperpotential expansive forces. 5. Emergence of higher-order structures. The model proposes that cosmic evolution resolves these instabilities through hierarchical restructuring. Orbital systems that remain stable are grouped together, forming higher-order configurations, effectively introducing a new level of organization, interpretable as a higher-dimensional structure. This recursive process leads to Atomic molecular stellar superstellar systems, suggesting an open-ended structural hierarchy. 6. Relation to established physics. This model intersects conceptually with classical gravitation, mass attraction and uncompression, although not mass collapse, but final explosion, electromagnetism, orbital structure with balance of charges, thermodynamics, energy density and stability limits. However, it departs from standard frameworks by redefining magnetic forces as a generalized expansion and redistribution principle, proposing cross-scale equivalence between atomic and cosmic systems, introducing a harmonic geometric interpretation of structure formation in any level. 7. Conclusion. The proposed framework suggests that orbital systems are not arbitrary structures but necessary responses to energy density constraints governed by gravitomagnetic interaction. Stability emerges only within a narrow balance range, beyond which systems either collapse or fragment, driving the formation of higher-order structures.